For this review problem, state without proof the fundamental theorem of arithmetic. As we've mentioned in class, fundamental theorem means really, really important. This is the principle behind factor trees. If n is a positive integer and n is at least 1, then it has unique factorization. N is equal to prime to some power times a bunch of other primes to some other power, where the p sub I are distinct primes and the a sub I are positive integers. The basic principle behind this is basically the idea of factor trees, which you probably learned when you're in school. So if you have a number, say 36, if we write this as a factor tree in school, we typically go 6 and 6, which would then go 2, 3, and then 2, 3. So that's one way of doing the factor tree. A second way of doing the factor tree would be 36. One of many ways this could be done would be to go 3 and then 12, and then 2 and 6, and then 2 and 3. And no matter what, no matter how the factor tree is done, first off, the factor tree stops. It ends with prime numbers. And also, no matter which way you break up the factors of the factor tree, you end up with the same factorization. 36 is equal to 2 squared times 3 squared. So that's the idea of the fundamental theorem of arithmetic, that no matter how you factor a number, there is a unique prime factorization that you end up with.